Dear students, now I'm going to start to discuss about the model question paper on physics. In any competitive examination, first job is what? After reading that particular question in detail, word to word, try to understand the question. After reading the question, immediately the idea should come in your mind whether this question belongs to which chapter. Next is, under that chapter, there are many concepts are there. It belongs to what concept it is. There are several formulas are there. Which formula I supposed to use it? And third point is what? Think it whether all the given parameters are they in the SI unit or need to be converted. Once you know that is this question belongs to so and so chapter and comes under the so and so concept and all that, then recall that a particular equation you have to recall it and then substitute the values and then calculate. And also second point is what? Always try to eliminate the unwanted answers are to be eliminated. Karodapati 50-50, like that. Suppose you eliminated A and C you eliminated, then the choice is left only with B and D. Now you start for thinking whether the B is right or D is more appropriate answer, like that. Okay, with this idea, always start for thinking or while solving the questions and all that. Okay. So now I'm going to start now. Calculate the steady current in the 2 ohm resistor shown in the figure here. He is asking the current in the what? 2 ohm resistor, that is 2 ohm resistor. The battery has negligible resistance and C equal to 0.2 microfarad. Now start for thinking why he is using the C here. The property of the C is what? Always it blocks DC. When it blocks the DC means no current will flow through the 5 ohm resistor. So just eliminate 5 ohm resistor. That's all. This is the first job. Second job is what? Simplify the circuit. Now here the 2 ohm resistance is there, 3 ohm resistance is there. 2 ohm and 3 ohm, how they are connected here? In parallel they are connected. So that you know the formula Rp equal to R1 into what? R2 divided by R1 plus of what? R2. Use this. It is 2 into 3 divided by what? 5. That becomes what? 6 divided by 5 equal to how much it is? 1.2. This is first part. Second one is here. Next is what? Here altogether it is what? It is 1.2 ohm resistance. It is 1.2 ohm resistance. This is 1. Anyway, we eliminate here. This is 1.2 and this is 2.8. How they are connected here? In series they are connected here. So that I am using R effective equal to 1.2 ohm plus 2.8 ohm equal to 4 ohm. That is. I know that the resistance equal to what? Net resistance equal to what? It is 4 ohm. What is the battery? I know that. What is the battery voltage here? The battery voltage is what? 6 volt. Of course, internal resistance is what? Neglected. Now I will calculate what is the current. The current equal to voltage divided by resistance. The resistance is how much it is? 4 ohm. And the battery is how much it is? 6 volt. Now you calculate I equal to V divided by what? R equal to how much it is? 1.5 ampere. This is first part. The total current in the circuit is how much it is? 1.5 ampere. But in our question, he is asking the current in what? 2 ohm resistor. He is asking the current in this. Now I have to use the formula for the branch currents. Branch for current formula, you have to use it. That is, we know that I1 equal to I into what? R2 divided by R1 plus of what? R2. This formula I am using. Just now I calculated current equal to how much it is? 1.5 ampere. I'll substitute this one. 1.5 ampere. Resistance of another branch, it is what? 3 ohm, that is 3 ohm, that is resistance of another branch is what? 3 ohm. Next, R1 plus R2 equal to what? 5. 5 ones are then simplified equal to what? 0.9 ampere. This is the current flowing in the what? The current flowing in this resistor is what? 0.9 ampere. This is the right answer. Next. Second question. The temperature at which the resistance of an iron wire would be 20% more than the resistance at 0 degrees Celsius. That means immediately this question belongs to what? The relation between resistance, temperature, and what? Alpha. This is the what relation. Here, immediately the question should come here, idea should come here in your mind. Here, R2 or R dash equal to R naught into bracket 1 plus alpha into what? Delta T. This formula you have to use it. Here, delta T is nothing but what? Delta T equal to T2 minus of what? T1. That's the formula. He is asking, T2 is asking here. But already T1 is known here. T1 equal to how much it is? 0 degrees Celsius. For this, I need to calculate delta T. I have to calculate here. And also, second thing is, remember students, here resistance is increases by what? 20%. Whenever the question comes, 20% increase, 10% increase. 20% means you write 1.2. Initial value is 1. If we say that 30% means you write 1.3. If it increases by 10% means what? 1.1. In this fashion, you should write it. Here, similar kind of problems are there in the first few problems also. That is. Now, what is the new resistance here? 120% more than the what resistance at this one. That means R dash equal to 1.2 of what it is? R naught. I don't know what is the value of R naught. I don't know that. It is not required also. Here I am using the formula R dash equal to R naught into bracket 1 plus alpha into what? Delta T. As I told you, it is 1.2 times of what? R naught equal to R naught into bracket 1 plus alpha into what? Delta T. 1 plus alpha delta T. This R naught is what? Get cancelled. Here, what is left here? 1 point. You transfer here minus 1 equal to what? 0.2 equal to what? Alpha into what? Delta T. Then delta T equal to how much it is? 0.2 divided by what? Alpha. Now substitute the value of alpha here. Substitute the value of alpha here. Here, delta T equal to 0.2 divided by alpha. What is the value of alpha? Value is how much is given here? It is 5 into 10 to the power of what? Minus 3. It is 5 into 10 to the power of minus 3. You transfer it here above plus 3 and altogether it becomes 200 divided by what? 5. 5 1 ja, 5 4 ja. This is what? 4. Delta T equal to T2 minus T1. Then T2 equal to, I have written here 40 minus of 4, 0, because T1 equal to what it is? 0. Then the change in temperature, at what temperature it is? 40 degrees Celsius. This is the right choice. See, this is the right choice. Sometimes similar kind of problems are there. The resistance is doubled, tripled. In that case, when it is doubled means you should use what? 2R. When it is triple means you should use what? 3R not, 2R not, 3R not, like that. Because many times question is awkward on that. Instead of asking percentage, he may say that it is increased by 2 times. It is increased by what? 3 times and all that. Next, third question. The resistances are connected in the 2 gaps of a meter bridge. Okay. 2 resistors are connected. The balancing point is 20 centimeter. Initial balancing length is how much it is? 20 centimeter. L equal to 20 centimeter. Next, a resistance of 15 ohm is connected in series with the small of the two resistances. He didn't told smaller, which is whether it is connected to the left side or right side. He didn't told. He used the word what small, that is 15 ohm resistance is connected. At the time, next time when you are connecting the 15 ohm, the null point is how much it is? 40 centimeter. Now we need to find the smaller of the two resistances. The smaller of the two resistances. Choices are 8 ohm, 10 ohm, 9 ohm, and what? 12 ohm. Students. Here the initial balancing length is what? 20 centimeter. When it is 20 centimeter, L is 20 centimeter, then 100 minus L, it becomes how much it is? 80 centimeter. Students, remember, this is left side. This is 100 minus of L1, it is what? In the right side it is. In the left side resistance is what? X. In the right side resistance is what? Yes. Students, remember, if L is less, X is less. If 100 minus L is less, S is what? Less. But in this problem, here L1 is less, left side, then certainly the left side resistance is smaller. This is the idea in it. Because he didn't told 15 ohm where it is connected. But he told that smaller, you should identify. That is what? X is the what? Smaller. Now I'm writing the two equations I'm writing. See? X by S, you know that. X by S equal to 20 divided by what? 80. This is equal to what? 1 by 4. Therefore, S equal to what? 4x. I calculate. This is first part. Second part you say. Here already I told you that is in the smaller resistance 15 ohm is connected. Here you see X plus 15 ohm. That is what I connected. I have not altered. S is not altered. At the time, the new balancing length is how much it is? 40 centimeter. So that X plus of 15 divided by S equal to 40 divided by what? 60. This, it cancels. What you are getting here? 2 by 3 you are getting. Now, this is the what? 2 by 3 and all that. And then simplified. Cross multiplication you have to do. The cross multiplication you have to do here. Now, after doing the cross multiplication and all that, here 3x plus of what? 45 equal to, what is this? Equal to 8x. Then you transfer it here. 45 equal to 8x minus of 3x equal to what? 5x. Therefore, x equal to what? 45 divided by 5 equal to what? 9 ohm. That is what? 9. Here, see, this is the right choice. 9 ohm is the right choice. In this question, what important concept is? If L is small, then X is small. If 100 minus L is small, then S is what? Small. It is normally X is connected in the left gap and S is connected in the what? Right gap. Next. Two concentric coplanar circular loops of radii 7 centimeter and 10 centimeter. You see, R1 and what? R2. Carry the current such that the net magnetic field at their common center is 0. There are two circular coils. This is circular coil and this is what? Another circular coil. Here the net magnetic field at the center is what it is? 0, he told that. Net magnetic field at the center it is what? 0. When magnetic field is 0 here, the magnetic field is 0, that means for one coil magnetic field is acting into the board and for another coil it is acting away from the board. This is possible only if current flows in the one coil clockwise direction and in another coil it is anti-clockwise direction. Understood or not? because net magnetic field is what? 0. The net magnetic field is 0. When it is possible here? Both magnetic fields should act in what direction? Opposite direction. This is possible if one current flows in the clockwise direction, and certainly in another coil, the current must be an anti-clockwise direction. You see, in the outer loop, current is 7 ampere. Then definitely in the inner coil, the current must be an anti-clockwise direction, so that either this is possible or this is possible. Now eliminate this, eliminate this. The elimination process is more important. But still I don't know this. Whether B is right or else what? D is right, that I don't know this. Next. This problem, it is belongs to what formula is? You know, the magnetic field produced by the circular coil at the center. That we know that formula. B equal to mu naught upon 4 pi into what? 2 pi into what? I divided by what? R. Of course, number of turns is what? Only 1. Here I don't want to carry this luggage, this luggage. Only the relation is what? I and what? R. That's why here I have written here I1 by R1 equal to I1 by R1 equal to I2 divided by what? R2. 1 minute. I1 divided by R1 equal to I2 divided by what? R2. I know the value of R1. R1 equal to how much it is? It is 7 centimeter. R2 is how much it is? 10 centimeter. Here, inner loop, and this is what? Outer loop here. Now, substitute here. Now, I1 divided by I1 divided by R1 equal to I2 divided by what? R2. This is outer loop, already told, 7 centimeter. It is what? 10, I think that is. This I1, that I don't know. What is the radius here? 7. Now, I1 equal to the cross multiplication here. It is, you know that 49 divided by what? 10 equal to how much it is? 4.9 ampere. This 4.9 ampere must flow in what direction here? Anti-clockwise direction. So that this is the right choice. While reading the only just read it, which is inner coil, which is outer coil. This is the radius is small, so that must be inner coil. This radius is more. This must be what? Outer coil. In the outer coil, current is how much it is? 7 ampere. Next. 5th question. A voltmeter of range 3 volt and resistance of 200 ohm cannot be converted into an ammeter. Or you may use gallonmeter also, no problem. You know the range of the voltmeter is how much it is? 3 volt. That is, and resistance is how much it is? 200. And this will be I equal to V by R equal to 3 divided by what? It is a voltmeter of range is how much it is? 3 volt. And resistance is how much it is? 200. Then how to calculate the current? Always in any competitive examination, you make it always denominator in terms of 10, 100, 1000, and it is possible multiplying by 5, dividing by what? 5. Then I equal to 15 divided by 1000. It is nothing but 15 milliampere. What is the range of the meter here? 15 milliampere. This is not possible to convert, which is not possible. Remember here. Here, this is always that is range of the emitter. Remember, very important point. Range of the emitter can be increased, but cannot be decreased. I can increase 15 milliamperes to 100 milliampere. I can increase it. I can increase 15 milliampere to 10 ampere. Also, I can increase it. I can increase 15 milliampere to what? 1 ampere also I can increase it. But I cannot decrease the range. That's why this is not possible. This is the right choice. It is not possible to convert 10 milliampere. What is important here? the range of the emitter can be increased. The range of the emitter range can be increased, but cannot be what? Decreased. What is the given range here? 15 milliampere. All are higher range, but 10 is milliampere smaller, so that it cannot convert into what? 10 milliampere range. Next. Sixth question. A proton and a deuteron of equal momenta is a plural of momentum, enter a uniform magnetic field normally. The ratio of their radii of orbits R1 is to what? R2 equal to what? He's asking. Students, in this problem, momentum is equal. Magnetic field is what? Same. This question belongs to the relation between, that is using the relation R equal to P divided by V into Q. In the question itself as is given, momentum is equal, magnetic field is also what? Same. So that P cancels, B cancels. So that R is directly proportional to what? 1 by Q. But now I have to think about charge. How many particles? 2 particles are using. One is what? Deuteron. Deuteron means what it is? It is one hydrogen, that is isotope of hydrogen, which contains what? One proton and one neutron. So that for a deuteron, it is what happens is the charge is what? Say Q equal to what? 1. For deuteron, Q equal to 1. And then for the proton is also what? For this also Q equal to 1. And for the proton also Q equal to what? 1. Charge is 1. Don't write exact value of 1.66. Don't write. Here also one proton. Here also what? One proton. So the charge is also what it is. Same. All are same. Then certainly R1 is to what? R2 equal to, ratio is asking 1 is to what? 1. So that this is the right choice. This is the right choice. Next question. 7th question. A solenoid carrying current is oscillating in a horizontal plane about its center in a uniform magnetic field with a period T. If the current is increased to what? 4I, then the period of oscillation. Students, this question is basically belongs to what? Vibration magnetometer. In vibration magnetometer, we know the equation P equal to 2 pi square root of I divided by M into what? BH. Students, here I is not current, it is what? Moment of inertia. B is magnetic field. M is magnetic moment. In this problem, current increases. Magnetic moment and current both are directly proportional. If current increases, then magnetic momentum is also what? Increases. Students, don't use I, don't use BH. Now you should connect the relation between T and what? M. How they are related here? T and M. T is directly proportional to square root of what? M. Inversely proportional. Now he is asking T2 here. T2 by T1 equal to what? Square root of M1 divided by what? M2, that is. Here, T2 divided by what? T1 equal to square root of M1 divided by what? M2 equal to square root of 1 divided by what? 4. Why I am writing 4 here? Because M1 equal to M, M2 equal to what? 4M. Because current will be increases how many times? 4 times. If current increases, then magnetic momentum is also what? Increases. How many times current increases here in the problem here? 4 times. Then current magnetic momentum is also increases by what? 4 times. Then you calculate it is 1 by what? 2. So that T2 equal to T divided by what? T1 is nothing but T. Here. I hope that is clear for you. That is. In this problem, don't carry this R moment of inertia and magnetic field. So that this is the right choice. First, as I told you in the beginning only, first recall that particular equation and eliminate the what unwanted things that is in that equation. Because he is asking the relationship between only T and what? M. You connect the only relationship between T and M. Don't carry I and BH. Next, 8th question. The magnetic lines inside a bar magnet, inside the bar magnet, you know that this is North Pole and this is what? South Pole. Always the magnetic lines of force always starts from where? North. Remember. Don't think that it will end at this point. It will continue with this. Magnetic lines of force are the closed curve, so that inside the bar magnet, it will start from where? South to what? North. So that converge at N pole and diverge at S pole from, or from its North pole to S pole from, or from South pole to what? That is 280 actually. South pole to what? North pole. This is the right choice. This is not right. So that the right choice is what, students? The right choice is here. This is the right choice. C is the right choice. Here. In this point, what is it? The difference between the electric lines of force and magnetic lines of force is also better to call it. Electric lines of force are not a closed curve, but magnetic lines of force are the closed curve. Remember, students. In electric lines of force, what happens? Slightly, I'm deviating from the actual problem now. Here, for this is plus charge and this is what? Minus charge. Electric lines of force will be like this here, or else it is like this, or else it is like this, like this. There is no continuity. There is no continuity between the positive and the negative. They are the open curves, but whereas magnetic lines of force are the what? Closed curves. Next, 9th question. If the temperature of a block of aluminum at 300 Kelvin is decreased, okay, temperature is decreased by how much it is? 20%, not 20. Its magnetic susceptibility is increased by, in the question itself it is given, temperature decreases. As temperature decreases, susceptibility increases. That means susceptibility and temperature are inversely proportional to temperature. Chi is inversely proportional to temperature. Here, initial temperature is T1 equal to what? 300 Kelvin. T2 equal to 20% less. 20% of 300 means 300 minus of 60 equal to 240 Kelvin. Students, I know the value of T1. I know the value of what? T2. He is asking the question, what is the percentage of change in the what? Susceptibility. What is T1 here? 300. T2 equal to how much it is? 240 Kelvin. So come to this. T2 we calculated here. Already we know that T1 equal to how much it is? 300 Kelvin. And use this relation, that is Chi2 minus Chi1 divided by what? Chi1. The final value of susceptibility minus initial value of susceptibility divided by what? Initial. It is equal to what? 1 by T2 minus of what? T1 and all. Yes, use this, simplify it and all that. Here, this is T1 minus T2. Okay, then divided by what it is? T2. Simplify it. Is it this? I think this is not required. T1, 1, and this is okay. Yeah, 1 divided by what? T2 minus 1 divided by T1 divided by what it is? Divided by T1, that is simplified. T1 equal to T1 minus of T2 divided by what? T1 into what? T2 divided by what it is? It is 1 by what? T1. This get cancels here. What is left here? After simplifying, what you are getting here, it is T1 minus T2 divided by what it is? T2 you are getting this. Because this I1 equal to what it is? 1 by what? T1 that is. It is not this one. It is 1 by what? T1. Here T1 get cancels. Here what is left here? Here left is what? T2 is left after simplifying. Substitute the value of T1, substitute the value of T2, then T2 is substitute here, then you are getting what? 0.25%, 25 in percentage wise, it is 25%. Because 300 minus 240 equal to how much? 60. Divided by what? 240. This get cancelled. It becomes what? 1 by 4. 1 by 4, how to convert? Denominator, you make it 100 or 1000 divided by what? This one. 25 into 4 equal to how much it is? 100. So that this will become 25 divided by what? 100. What is 2500? 0.25. In percentage wise, it becomes how much it is? 25%. So that the right choice is what? It is 25%. So that the right choice is what? 25%. Next. 10th question. In the circuit shown in figure, the AC source V equal to 20 into cos of 200 omega t. 2000 t, sorry. Neglecting the source resistance, the voltmeter and emitter readings will be. Okay, the circuit diagram is drawn. This problem, it belongs to what? LCR circuit. And also you need the knowledge of AC voltage unit. Here you see this voltmeter is connected. Where it is connected? Across L and C. Whenever the problems comes on the LCR circuit, majority of the problem, students, belongs to the what? Resonant circuit. Majority of the problem. I will not say that all the time. Here, V equal to, you say, V equal to, what is that? 20 into cos of, it is 2000, I think. 2000 into what? 2000 into what? This question, that is similar equation is V equal to V naught into cos of omega into t. Compare it. This is 2000 and this is what? Omega. Omega equal to 2000. V naught equal to V naught equal to 20. Here. Got the idea? Maximum voltage equal to how much it is? 20. Omega equal to what? 2000. Now, think it, whether the circuit is resonant circuit or not. How to check that circuit is resonant or not? For that, here, calculate XL equal to what? Omega L. How to calculate XL? XL equal to omega into L equal to 2000 into, what is the value of L? The L value is how much it is? 5 millihenry. This is 5 millihenry. Okay. I'll substitute 5 into what? 10 to the power of minus 3. Then this is plus 3, minus 3 get cancels. It becomes 10 ohms. Already written here. XL equal to how much it is? 10. Similarly, you need to calculate XC. XC equal to 1 divided by omega C. 1 divided by 2000 into, you see, C equal to how much it is? The value of C is how much it is? 50 microfarad. It is 50 into what? 10 to the power of what? Minus 6. Substitute all the values. Then after substituting, and XC is also, you are getting how much it is? 10. XL is 10 ohm and XC is what? 10 ohm. What you understood by this? It is the reactance of inductor is equal to the reactance of the what? Capacitor. When this is possible, VL equal to what? Basic. It means the circuit is a resonant circuit. It's a resonant circuit. Whenever it is a resonant circuit, remember, it is an LCR circuit is nothing but resistive circuit. Only resistive circuit. Don't write current equal to V by Z, but you write I equal to V divided by what? Because it is only a resistive circuit. Next point is, when the circuit is resonant circuit, remember the voltage across the V inductor is equal to the voltage across the capacitor. Not only that, both how they are equal and opposite. VL and what? VC. Both are equal and opposite. That is the beauty of AC voltage. It is a vector addition. When they are equal and opposite, so that the net voltage shown by the voltmeter, it must be a zero. That is zero. The reading of the voltmeter is what? Zero. Now you see the choice. Here also voltmeter is zero. Here also it is what? 0 volt is there. Definitely this is not a right answer. This is also not a right answer. Now you should start for thinking whether A is right or else what? C is right. That I don't know. Now just bother about current. Current equal to voltage divided by what? Resistance. What is the voltage here? Voltage equal to how much it is? 20. It is not only voltage here, peak voltage I naught equal to V naught divided by what? Equal to, is substitute this. It is 20 divided by what? 10. What is 20 by 10 equal to what? 2 ampere. Students, it is not 2 ampere. He is asking emitter reading shown by the what? Emitter. That means we know that all AC meters, it measures what? RMS values. But what I measured here, that is what? Peak current I measured here. That is peak current. I measured. But I need RMS current I need. How to measure the RMS? IRMS equal to I naught divided by what? Root 2, that is equal to 1.414 ampere. So right, which is the right choice? Voltage is 0. Current is how much? 1.4 ampere. This is the right choice. Anyhow, I told that this is not, this is not. Again, this is also not a choice. Students, I forgotten here. Why I have taken the resistance 10 ohm here? Because I have taken the 10 ohm. Because here the resistance is 6 ohm. And this resistance is what? 4 ohm. Inductor also has got some resistance. Both how they are connected? Series. So that the net equal to 6 plus 4 equal to what it is? 10 ohm I have taken here. Okay. Now, students, I will stop the discussion now. That is. Thank you.